A real turning point over here is when we started thinking of the air as sort of a friend of the car. We started using the air to make our cars better. And I think Colin Chapman, who was the founder of Lotus, was one of the most innovative people in this area. And he said that he thought about planes and their wings and thought, what if we flip the wing? And essentially use those wings to then make our cars stick to the ground. And that's how downforce was essentially born in F1 as well, where you had these giant wings they put on cars, front wings and rear wings, which are now staple in F1 cars, but back then were revolutionary. Essentially, what these wings do is that the air passing over them, these wings direct the air to stick the car to the ground. If a car sticks to the ground, you have better traction, better power delivery on the ground, and you also have better handling for corners. And the cars, when they stick to the ground, are able to handle much better in the corners. And aerodynamics and downforce was essentially a huge game changer for F1. It made cars way faster, cars way more nimble. And this essentially philosophy change of using the air to our advantage also changed aerodynamics forever in cars. And you see spoilers and you see wings in cars these days, and that's essentially the purpose that these serve in using the air in a way to help us do better. However, there's a bit of a downside to this, which is that when you have a big wing at the back of a car, it also creates additional drag, which is the exact opposite of what you want. So you have to sort of find a balance in it. Another very cool thing that has been able to born. Yeah.
Sorry to interrupt, but you stated how obviously it creates a consequence on the wing behind. And we started this full discussion off with Colin Chapman, who is like arguably, I would say, the greatest automotive engineer to exist in the Formula One industry.
Yeah.
But he created, of course, the concept of downforce. But what Colin Chapman also created a few years later was the concept of ground effect. Ground effect was really interesting in the sense that it sort of it undid all of Chapman's work early on. So he created the concept of these complex wings and these huge barge boards and all of that. And what ground effect did was basically say that, okay, we know how we can generate downforce through these wings and through these barge boards and everything. Now let's try doing it through airflow underneath the car. Which is why what Colin Chapman did was he exploited how air flows around the skirts of the car and around the underfloor of the car. And the reason it's called ground effect is basically it takes the air flowing under the car, so the air between the ground and the floor of the car, to be a sort of part of the aerodynamic system which you're dealing with, which is why it was called ground effect. And of course, the consequence of ground effect was, again, more downforce. And the reason it was sort of banned at one point was literally because cars got too grippy, like far too grippy, in the sense that the amount of downforce they were generating was so ridiculous. Downforce to a certain point is also sticking down, but what ground effect was doing was it was sucking things up because of how strong
actually,
it was.
one second, I'll just interrupt you quickly over here for a second. Just to like give a brief idea of what ground force is from a technical standpoint. Ved, why don't you take us through what ground force is, like how it actually works, and why it's different from typical wing as downforce.
Yeah, so as Akshay mentioned earlier, actually, like with downforce, right, you have this side effect which is drag, and drag is pretty terrible for the car because one, it actually reduces the maximum speed that the car can go at, and two, it also lets out sort of, I think you can think of it as dirty air, but basically it lets out this turbulent air from the back, which is actually really harmful and a huge obstacle to cars that are behind you, right? Cars that are actually really close, like maybe 2 car lengths behind you. It reduces their downforce a lot too, maybe as much as like almost by half. And this is a huge problem, right? For both cars actually. So then you can utilize what's called the ground effect to sort of like counter this. So to sort of like get the benefits of downforce without actually having to deal with drag. And the ground effect actually works on the Venturi principle, which is I'll explain it. So basically, if you have a tube, right, or any sort of passage of air where air molecules flow, the air molecules in one end will enter at the same rate that they leave on the other end, right, which sort of makes this constant flow of particles. But if at any point, like say the middle of the tube, you sort of restrict the size or the width of the tube, right, there's a smaller amount of space through which the particles can go through, but they have to go through it in the same like number. So what ends up happening is they go a lot faster. So you actually do this like as Hushrav said, between the floor of the car and the ground. is you actually limit the space over there, so the air sort of moves faster. What this does is it creates this sort of low pressure area near the bottom of the car, which in turn creates a high pressure area towards the top of the car, and this basically creates sort of vacuum or suction region where the air can move really fast, and this presses the car down, creating this alternative drag downforce without involving any sort of drag. So that's why the ground effect is really cool that way, in which it takes all benefits of adding wings and like the reverse, the inverted plane wings and the spoilers in the back of the car. It gives you all the advantages of using that sort of a system, and that it gives you the downforce that you need, but it gets rid of all the drag that comes along with it.
I mean, I think ground effect is a really, really, really beautiful real life example of Bernoulli's principle. I mean, it is, I would say, Bernoulli's principle at its technological finest, in the sense, again, like Bernoulli's principle is exactly what Ved explained. It's basically an increase in the speed of the fluid that occurs because you sort of decrease the pressure, or you decrease the potential energy of the fluid going through it. So the best way to explain it is you take a tarpaulin on a windy day and you sort of put it outside, and the top is naturally going to submerge because of the air. But when it submerges, the space between the ground and the base of the top is decreasing. But as the space keeps decreasing, the air under the top is going to flow that much faster from under the top. And that's what, as Ved said, is what ground effect exploited. Ground effect was created to make air flow around and under the car much faster in a more centralized fashion. So I think, that's what makes ground effect.